Example: between 2009 and 2012, President Obama repeatedly made the following promise with the Affordable Care Act. If you like your healthcare plan, then you can keep it. Under which of the following scenarios would you think the president's promise was kept? 1. You like your healthcare plan, but you can't keep it. 2. You don't like your healthcare plan, but you can't keep it. 3. You don't like your healthcare plan, and you can keep it. In scenario 1, the premise is true, but the conclusion is false. In that case, the president's promise was not kept. In scenario 2 and 3, the premise of the conditional is false. Thus, the conditional is true, and the promise should be considered to have been kept. Notice that in a truth table, when the premise is false, the conditional is true, regardless of what the conclusion, what is the conclusion, true or false. Example: let M represent the statement Bill is a math major, and let C represent the statement Bill is a chemistry major. Represent these combinations of statements in symbolic form. Determine which are true under the assumption that Bill is a math major but not a chemistry major. Bill is a math major or chemistry major. Bill is not a math major and is a chemistry major. If Bill is not a math major, then he is a chemistry major. So M or C, the disjunction is true since M is true and C is false. Not M and C, the conjunction is false since not M is false and C is false. Not M implies C, the conditional is true since not M is false and C is false. Truth tables for complex statements. We can use the basic truth tables presented above to analyze more complex statements. Example: consider a statement. If you do not remember the past, then you are condemned to repeat it. Let P be you remember the past, and Q you're condemned to repeat the past. We have to make a truth table for not P implies Q. Here is a truth table for not P implies Q. Note that we start with P and Q. We fill in all the possibilities for P and Q. Right, so P can be true and P can be false. Right, so for each possibility for P could be true, Q could be true, P could be true, Q could be false, and P could be true false, then P is true, P is false, Q is false. Right, so we just fill in all the possibilities here. Then we'll find not P and we'll fill in the column. Then we evaluate the conditional. For example, not P implies Q is true when both P is true and Q is true. This fact is relevant to those people who remember the past and are condemned to repeat it. Example: in 1994, California voters approved Proposition 187, which included the statement, "A person shall not receive any public social services until he or she has been verified as a United States citizen or as a lawfully admitted alien." The law was later judged unconstitutional by a federal court. Let C equal to citizenship has been verified, and A equal to lawfully admitted alien status has been verified. Then under Proposition 187, the condition that would deny services is not C or A. Use a truth table to analyze this statement. Right, so we fill in the truth table. We start with C and fill in the values for C. A, fill in the values for A. Then we evaluate the statement within the parentheses. Once that statement has been evaluated in the truth table, we find a negation of that statement. The services would be denied to people who are neither citizens or lawful aliens. So this is a line here. More on the conditional. Converse, inverse, contrapositive. The conditional is a combination of statements that is most often misinterpreted, so it deserves further attention. Assume that P is, you support my bill, and Q is, you're a patriotic American. P implies Q. If you support my bill, then you're a patriotic American. The conditional P implies Q is, if you support my bill, then you are a patriotic American. The converse is Q implies P. If you're a patriotic American, then you support my bill. The inverse is not P implies not Q. If you do not support my bill, then you are not a patriotic American. The contrapositive is not Q implies not P. If you're not a patriotic American, then you do not support my bill. In this truth table, we analyze which of these four options are equivalent. Notice that the conditional is equivalent to the contrapositive. So P implies Q is equivalent to not Q implies not P. The converse and inverse are also equivalent. Right, so Q implies P is equivalent to not P implies not Q. Two statements are logically equivalent if they have the same truth table. Conditional statements. Consider the conditional statement. If a statement A, then statement B. The contrapositive statement is, if statement B is false, then statement A is false. A conditional is logically equivalent to its contrapositive. The converse statement is, if statement B, then statement A. The inverse statement is, if statement A is false, then statement B is false. The inverse is logically equivalent to the converse. Replacing a conditional statement with its inverse or converse is not logically valid. Example. Formulate the converse, inverse, and contrapositive of each of the following conditional statements. If you vote for me, your taxes will be cut. And all Democrats are liberals. For the first one, the solution is the converse. If your taxes are cut, you voted for me. The inverse is, if you do not vote for me, your taxes will not be cut. The contrapositive, if your taxes are not cut, you did not vote for me. 2. The converse, if you're a liberal, you're a Democrat. The inverse, if you're not a Democrat, you're not a liberal. And the contrapositive, if you're not a liberal, you are not a Democrat. The logic gate AND takes two inputs, each of them 0 or 1. It corresponds to the logical operation of conjunction. If the inputs to the AND gate are 1 and 1, what is the output? This situation corresponds to the conjunction P and Q when both P and Q are true. The output of a logic gate is 1.